Well, good morning or good afternoon. We're here with my Period 2 class. I'm going to go over questions 1 through 16 on the Unit 2 gas laws. So, ladies and gentlemen, I'd appreciate your help here. So first off, define the following with an equation. Charles' law. Well, that's looking that up. We're going to provide those on the test, but it's going to be volume 1 over temperature 1 equals volume 2 over temperature 2. I suggest that you always, let me zoom in here so it's easier to see that, cross multiply those. Charles's law becomes V1 times T2 equals V2 times T1. Boyle's law, that's the one on pressure. We got pressure 1, volume 1 equals pressure 2, volume 2. That one's already set up for you rearranging the equation. So you don't have to have these memorized. They're going to be there. Gay-Lussac's law deals with pressure and temperature. Pressure 2 over temperature 2. Now, in our review, any of these laws that have temperature in it, they are directly proportional. So directly proportional if T is involved. The only ones that don't have T are going to be Boyle's law. It's inversely proportional. So coming over here, standard pressure. Okay, everybody, what is it, period 2? How many degrees Celsius? 0. How many kelvins was that? Oh, you're awesome. This is easy. I'm going to do this more like this all the time. Now look it. You will have this chart given to you on the test. So you just need to know how to use it. The only thing you won't have is what we added, the standard temperature and pressure. So filling in here, it's going to be 1 atmosphere, 760 torr, 760 millimeters of mercury, 101.3 kilopascals. This is given to you. You don't have to have any of this memorized. That should be 29.92. And I think this one was, oh, help me out, 14.7, right? Okay. So those are just all the different ways that we've measured standard pressures. So that's just filling it out. You need to convert this atmospheres to torr. So you always do 3.2, the given. Don't get lazy. Please put these out. I will be awarding 10 points on the test for students that annotate and show their work. If you don't annotate and show all of your work, you just don't get 10 points. So now we need to be able to diagonally cancel out the atmospheres, which means we have to have atmospheres here, and we want it to be in torr. And you look on your conversion chart, it's going to be 760 torr to 1 atmosphere. I'm not going to do the math. You can do it there. For number 4, same thing. You're going to set up 890 millimeters of mercury over 1, the given, and then you need to multiply it by the appropriate. Now we want to go to atmospheres here, so we want to have atmospheres up there. We want to put millimeters of Hg over here of mercury, and let's see, 1 atmosphere is 760 millimeters of mercury. If you could diagonally cross these out, you've set this up correctly. And assuming you know how to use a calculator, you should have that correct. On this one over here, okay, I'm just going to shortcut here. I'm going to put that over 1, okay? And we want to go to kilopascals. And so, oh, sorry about that. Sorry. So we've got our given over 1. We want to go to kilopascals. And it's, now be careful, it's 101 kilopascals. I think it's a little easier on the chart. So I'm going to put 101.3 kilopascals. Is going to be the same as 1 atmosphere. So to do that problem, you're just multiplying the given by the conversion factor of 101.3. All right. To convert Celsius to Kelvin, if you forget, it's here on your reference chart. And you're just going to add plus 273. I'm not going to do that here. You can do that. What is absolute 0? Well, in real terms, it is 0 Kelvin, which would be negative 273 degrees Celsius. But what it is, it's the temperature where matter actually stops moving. Where matter stops moving. It's when matter truly is frozen. I mean, there is no more molecular vibrations at all. We've never been able to get there yet. We've been really close, but not quite all the way there. Define and explain how energy, heat, and temperature are different. Well, energy is the ability to move molecules, so ability to move molecules. Heat is the flow of energy, high to low. Temperature is what we measure kinetic energy with. Measure of kinetic energy. Or a measure of heat, if you like. Measure of kinetic energy, which we basically say is the same as heat. It's just a measure of it. Okay, so they're closely related. They all have to do with molecular motion, but they're different. This is a value. This is a measurement of how this heat flow is going. And heat flows from where there's a lot of moving molecules to where there's low moving molecules. Number 9, what happens to the kinetic energy? I'm going to label that KE. I also told you, remind yourself that that's heat, and it's also going to be temperature, okay? That's how we measure it, of molecules as they're heated up. Okay, so that means heated up, if you're increasing the temperature, these are all directly proportioned. The kinetic energy increases, the heat increases, the temperature increases. The molecules start moving faster. Number 10, did I answer? Okay, there. Oh, cool down. I didn't get that part on that problem. Well, okay, if you cool down, temperature's decreasing, and you're going to have less molecular motion, less kinetic energy. Number 10, are solids, liquids, or gases easier to compress? Okay, liquids and solids cannot be compressed. No squeezing here. That's what compress means. Liquids and solids, draw a diagram. Solids are locked in a crystal lattice structure. They can vibrate, but they cannot move. You can't get them closer. Liquids are free to move. They can move around. They're not locked in that crystal pattern, but they cannot be squeezed at a tiny bit, but for the most part, we say you can't squeeze them a little bit. When they heat up, they can expand, as that's what makes convection work. Now, gases can expand because they are far apart to begin with. They're moving really fast compared to the other materials, but they have room. If you've got this big container, you can squeeze it into a little tiny container like this. And if you do that, they are bouncing around and moving. I mean, and that makes the pressure increase and it causes problems. But you can squeeze a gas because there's room in between them. Number 11. How does the pressure inside a container increase? So pressure is increasing if more gas is added. Well, it's almost like we're doing this. If we have that much gas in a container, 4 particles of gas, and if we squeeze in twice as much into there, they're going to bump into each other, and pressure equals number of collisions. I just opened a Twitter account. I should start hashtag number of collisions. I've never done a hashtag. Okay, so focus. Number 12. Okay, if the volume of a container of gas is doubled. Okay, V increases times 2. What will happen to the pressure? Okay, period 2. Pressure and volume, are they directly or inversely related to each other? They're inversely. So the pressure is going to go down, and since we made this one twice as big, this will be half, or it's 2 times smaller. Answer and show or explain why. Okay, number 13 here. If pressure doubles, pressure goes up times 2. Well, we said pressure and volume. Well, I'm sorry, that's the same question. I apologize. It's just the same. Volume decreases 2 times, becomes 1/2 because they are inversely related. Inversely proportional. The pressure reduces by, this was weird. Sorry for the typo. If pressure reduces by becomes 1/4, okay, pressure is going down 4 times, is what I'm taking. What's going to happen to the volume? First off, will volume go up or down? Up. So if the pressure goes down by 4 or becomes 1/4, the reciprocal of 1/4, volume will be 4 times bigger. Sorry for the weird wording on that one. I'll have to fix that one. If temperature doubles, temperature increases times 2. What happens to the volume? Are they directly or inversely related? Pardon? They're directly, so that means that the volume will increase by 2 as well. They are directly proportional. And the memory clue is, if you got the T in direct, if it has temperature, they're directly proportional. Oh, this one over here, we said they were inversely. If temperature reduces by 1/4, okay, sorry for the bad wording, temperature decreases 4 times or becomes 1/4, Volume, are they directly related or inversely related? They are directly. So this will increase, oh, sorry, this will also decrease by 1/2. My mistake, sorry about that. Decrease, they're directly proportional. Let's see, if pressure reduces, is this oh, we're doing temperature now. So pressure goes down 1/4. Are pressure and temperature directly or inversely proportional? They're directly. And since they're directly, this will also go down by 1/4 since they're directly proportional. If pressure doubles, okay, pressure increases by 2. We already said in this one that they are directly proportional. So that means that the temperature has to go up by 2 as well. So, almost done with the video. I appreciate your attention to this. Let's see. Number 14, the volume of a gas is reduced. Okay, volume is going down, and it's going from 10 to 2. I'm just going to go 10 divided by 2. What is 10 divided by 2? So what's happening is the volume is going down 5 times. Okay, let me see. How does pressure, okay, are pressure and volume directly or indirectly proportional to each other? Does volume or pressure have the word? They are inversely. So that means if the volume's going down 5 times, what's pressure going to do? Go up 5 times. There will be a problem similar to this, so you just need to divide this out, find out what the change is, and then apply it. Almost done with part 1. Okay, if a gas is heated, okay, heated, that means temperature is increased. What happens to the volume of the volume of the gas? So what's volume going to do? Temperature and volume, are they directly or indirectly related? The volume's going to go up too. That's assuming that the pressure doesn't change. And lastly, and then I can turn this off and get your specific questions. How does the pressure of a gas, okay, pressure of a gas change if the temperature is increased? Okay, are these two directly or indirectly proportional? They are directly. A memory clue there is if you got T involved, there's the T indirectly. So that means the pressure is going to go up also. Part 2. Okay, if the temperature decreases, well, then since they're directly proportional, the pressure is going to decrease as well. All right, so I'm going to end right here. And farewell. Or as they say at Fresno State, so be it!